In the lesson today, you're going to have more practice with dividing integers, and for our first question here, we're told that the shapes shown are used to show the relationship between each of the four equations in the same fact family. Suppose that the star represents negative 24. What values could the other shapes be? Okay, so all of these stars are equal to negative 24. So I'll just go ahead and put these negative 24s in there to help me with the stars. Okay, and they want to know, well, what values could the other shapes be? So all I have to do is think of some fact families that would give me a negative 24. If I'm multiplying, well, maybe I could use the numbers like they did over here, 8, and then maybe it's a negative 3. Okay, maybe it's a negative 3. Or maybe the 8 was negative and the 3 was positive. The signs have to be different in order to get a negative answer. Maybe it's not 8 and 3s. Maybe it's another way to make 24, like with a 6 and a 4. So maybe we have a 6 and a negative 4. Or maybe we have a negative 6 and a positive 4. Again, the signs have to be different in order for us to get negative 24 as our answer. Maybe if we're dividing this time, okay, I've got a negative 24, and again, I've got to think of two numbers that I would multiply together to get to a 24, and maybe it's going to be a 12 and a 2. So maybe I've got negative 24 divided by 2 equals negative 12. Or maybe I make the 2 negative, negative 24 divided by negative 2, that would make this a positive 12. Okay, or maybe it's even with a 1 and a 24, all right? Negative 24 divided by negative 1, well, that would have to equal 24. There's lots of different fact families that we could use in order to get to the 24, and these are just some examples of those. Now, what do you know about the square and the circle if the star represents a negative number? Okay, so if the star is a negative number, okay, well then that means that the square and the circle must have different signs. The square and the circle must have different signs. Okay, the product of two numbers that have different signs is negative. Okay, the product of two numbers that have different signs, as well as the quotient of two numbers that have different signs, is going to be negative. In example 1, we're told that a machine is used to access water under the ground. If the machine drills the same distance each day, what is the change in the location of the bottom of the hole each day? Write a division expression and use the number line to show the change in location. Okay, and so if we look at the picture here, we can see where it was at the end of day 1, day 2, day 3, and day 4. And the water, we're told, is 160 feet below ground level. Okay, so if we think about this on our number line, okay, this top line is going to be the ground, which is going to be the integer 0. All right, and I'm drilling down the same each time. I'm going down, that's for day 1, for day 2, for day 3, and for day 4. And at day 4, this is when I get to the water, and they're told it's 160 feet below ground, so this has to be the number negative 160. Okay, so I've got to figure out what I'm doing here. Okay, I've made it 160 feet below ground, and I dug the same amount every day. And so I can use a division problem to represent this. I can do negative 160 divided by the 4 days in order to figure out how much I had to dig down each day. Okay, and so if I do this division, all right, negative 160 divided by 4, well, that's going to give me an answer of negative 40. Okay, so at the end of day 1, we're at negative 40 feet below the ground. At the end of day 2, we're at negative 80, all right, 80 feet below ground. At the end of day 3, we're at negative 120 feet below ground. And again, at day 4, this is when we got to the water at 160 feet below ground level. So what does this negative 40 mean? Well, we can say that the location of the bottom of the hole went down 40 feet each day. Okay, I know it's a negative number, which means that it's going down 40 feet each day. In our next example, it says, suppose that the machine drilled the same distance into the ground for 3 days and reached water at 84 feet below ground level. What was the change in the location of the bottom of the hole each day? Okay, so again, we're going to start here at the top, which is the ground at 0. And we're going to dig down 3 days in a row. Day 1 gets us here, day 2 gets us here, day 3 gets us here. And at the end of the 3rd day, we're 84 feet below ground level when we hit the water. Okay, so we're going to take our negative 84, and we're going to divide it by the 3 days to figure out how much the location changed each day. And if I do negative 84 divided by 3, I get an answer of negative 28. So at the end of day 1, we're 28 feet below the ground. At the end of day 2, we're 56 feet below the ground. And at the end of day 3, when we get to the water, we're 84 feet below the ground. So again, we can say, actually it's down here. Each day, the location of the bottom of the hole changed by negative 28 feet, which means that it decreased by 28 feet. In the next example, they want us to simplify negative 27 divided by negative 3. And we're going to do this 2 different ways. In method number 1, we're going to use related multiplication. And in method 2, we're going to use properties of operations. Okay, so let's start with method 1, which is the related multiplication problem. All right, here they tell me that negative 27 is being divided by negative 3. So negative 3 times something has to equal negative 27. Okay, well, the only way for that to happen is if I multiply negative 3 by positive 9. So if negative 3 times 9 equals negative 27, that must mean then that negative 27 divided by negative 3 equals positive 9. With our properties of operations, we're going to do the division problem again. And I'm going to write the division problem like a fraction this time. I'm going to write negative 27 divided by negative 3. Again, a fraction represents division. And I can rewrite both of these numbers in a different way. Negative 27 is the same as negative 1 times 27. And similar to that, negative 3 is the same as negative 1 times 3. Okay, so if I think about this as 2 different problems here, in the first problem I've got negative 1 divided by negative 1. And then in the other problem I've got 27 divided by 3. And I'll just multiply those numbers together. And so if I've got my 2 different divisions here, well, negative 1 divided by negative 1 is 1. And 27 divided by 3 is 9. Well, then that must give me an answer. 1 times 9 is equal to 9. So again, this is just a different way to show that negative 27 divided by negative 3 is equal to 9. In the last example, you were taking the number 0 and dividing it by negative 40, and the answer was 0. And that's always going to be a true fact, all right? If you're dividing the number 0 by a number, the quotient will always be 0. Okay, 0 divided by any number is always going to be 0. All right, but if you divide, if you're dividing a number by 0, okay, well, this can't happen, and we call that undefined. Okay, so for example, 6 divided by 0. Okay, I can't take something that has 6 objects in it and divide it into no groups. Okay, there's always going to be some sort of group. So this can't happen. You can't divide by 0. That's undefined. But 0 can be divided by a number. 0 divided by 6 is equal to 0. One other important piece of information we need to talk about is the placement of the negative symbol when we write our division like a fraction. And in this example, okay, I want to know, are the following quotients equivalent to each other? Here I've got negative symbol out front. Here I've got the negative symbol in the numerator. Here I've got the negative symbol in the denominator. Okay, and I'll start with these two examples because we know our division rules. This is a negative number being divided by a positive number. This is going to be a negative number. I know that. And now I'm just going to ask myself, well, 4 goes into 18 4 times. Okay, and 4 times 4 is 16. That means that there's 2/4 left over, but 2/4 is the same as a half. So this answer is negative 4.5. Very similar to this one over here, it's a positive divided by a negative. So again, my answer has to be a negative. And if we do the division again, 18 divided by 4 is going to give us that 4.5. So these two are at least the same, okay? The negative symbol can be in the numerator or the negative symbol can be in the denominator. What about when the negative symbol is out front? Well, when the negative symbol is out front, that represents the number -1. This is the number -1 multiplying 18/4, or 18 divided by 4. Okay, and if I do that division, I know right here that 18 divided by 4 is going to give me that 4.5. So this is really the same as -1 times 4.5. And then when I do that multiplication, a negative times a positive is negative, and 1 times 4.5 is 4.5. And so we can see here, yeah, all three of these really are the same value. So it doesn't matter where you place the negative symbol in the fraction. It can either go out front, or it can go in the numerator, or it can go in the denominator. The important thing to realize, though, is that there's only one negative symbol, okay? There's only going to be one negative symbol, either in the front, the numerator, or the denominator. In the last example, I want to know which of the following are equivalent to -5. And so this again is going to be talking about the placement of the negative symbol in our fraction. And our first one here, 55 divided by 11, well, that's a positive divided by a positive. This is just going to equal +5. And so I know that this one is not equivalent to -5. All right, if I look at the next one, okay, the negative symbol's out front, which remember is the number -1. So this is -1 times 55 divided by 11. And that again is -1 times 5, which is equal to -5. So this one's good, okay? This one is equal to -5. All right, in the next one, my negative symbol is in the numerator, all right? A negative divided by a positive is negative, and 55 divided by 11 is 5. So this one looks good as well. Okay, in this one, I've got a negative divided by a negative, which is going to be a positive number, okay? This is going to equal +5, so this one is not good. In this example, my negative symbol's in the denominator. A positive divided by a negative is going to be negative, and 55 divided by 11 is 5, so this is -5, so this one looks good. And now notice this last one. This one looks pretty complicated. We've got a negative symbol out front and in the numerator and in the denominator. So let's first address the negative symbol out front. And remember, that's the number -1. So this is going to be -1 times -55 divided by -11. Okay, so that's going to be -1 times, well, remember, -55 divided by -11, that was +5. So this is just -1 times 5, which is equal to -5. So this one is good as well.